Okay, friends, so I know I left you hanging on this question number 30, and we're going to answer it in this video, just so you know. I wasn't going to leave you hanging on it forever. But there's confusion, right? I mean, how can this answer be 11% and this answer up here be 70%? They're nowhere near each other. Okay, and the answer really lies in this axis. I don't know if you remember in that previous video, I said, be careful when you're reading this axis because the axis doesn't go to 0. Well, that's confusing. It should go to 0. I mean, if this is 70, which is 70 US dollars, that should be $70 above 0. This should be $65 above 0, $60 above 0. This 50 being here, if you see 50 here and this line here at the bottom, your brain thinks that's 0, but it's not 0. So why should you trick your brain with a graph? This down here is what the graph should look like. I got to zoom out a little bit so you can actually see the whole thing. It's definitely, it's not as conveniently shaped as the one we had before, but that, my dear friends, is actually what the graph should be, because what you're seeing now is you're seeing the actual 0 number at the bottom. So, first question, number 31. How is this graph similar to the last one? Well, heck, it's got the same movement up top, right? Look at the shape. Shape's the same exact shape. How is it different? We just said that. It's different because this one goes to 0, and that makes all the difference, and here's why. Look back to your answers from number 27 and 29. Remember, 27 was the one where we got 70%. It's about 70% of the high price. 29 was the 11%. What we're going to do down here is we're going to say, all right, which one this graph aligns with. Now, I'm not going to redo number 27 because number 27 is going to be exactly the same. If I pull the number that goes with this bar here, I'm still going to get whatever I got. What I need to do now is re-measure those bars and see. So what I'm going to do is I'm going to do exactly the same thing I did before in Paint. But instead of using this graph, I'm going to select all, delete, and then paste this new one in and shrink it down so we can see it. Okay. I think this is I'm going to have to use Camtasia to zoom in here a little bit to make that look better. Okay, just like we did before, we're going to grab this little dude here. We're going to copy and paste him. He becomes our ruler. Okay, so there's 1. Now, unlike last time, this is not, we can't repeat that again because the red bar isn't tall enough to repeat this. So we're only going to have to repeat a portion of this yellow bar. So let me take about half of it. Copy, paste. Okay, that's too much because you can see if I stack those on top, it's going to go past the red bar. So that's too much. What if I took like a third of it? That's about a third, right? Let me see. That's a half. That's about a third. Okay, copy and paste. That looks pretty good. Yeah, that's just about right. It's a little bit shy. So maybe we can call it a third. Or we can say maybe it's 0.4. And don't worry about the math I'm doing right now. I'm just trying to get you a ballpark. That's probably closer to it. Copy, paste. That looks better, actually. Okay, that's more like 0.4. So this red bar here is actually 1.4 of the yellow bar. So if I use Google as a calculator, let's pull it over here, and I do 1 divided by 1.4. Let's see what I get. Look at that, 71%, which almost agrees perfectly. Remember back, that almost agrees perfectly with what we got up here in 27, which means when we use the numbers, which were correct, we matched this graph down here. So how the heck did this graph misrepresent itself so bad? And the reason is all due to the fact that this isn't 0. When this isn't 0, your brain doesn't realize. I mean, you can read this and realize that, oh, this only goes down to like 46 or something. But your brain still compares that line to this line and says, whoa, that line is so much smaller than this line. Even though your brain knows these numbers are over here, it's still confused by the bars. That's why this graph is actually the correct one. Now, why didn't they publish this graph? We're getting into this now. Let's talk about why. We're doing that right now. One reason the creator of the original graph may have done that. Okay, the original graph was this one. Well, they called it Papa's Plunge. They want to make it look worse than it actually was. This looks like a humongous drop. It's a drop of 90% visually, even though it's only a drop of about 30% mathematically. If you were to take this graph here and print it, it wouldn't look as excessive because it doesn't fall from like here all the way down to the bottom corner. So the reason that this is misleading by the size of the bars is entirely due to the fact that they don't start this vertical axis at 0. Pay attention to this, friends. It is incredible how often news sources do this. Now, part of it, I think, is innocent and innocuous. In other words, I'm gonna take some of these lines out. So, why don't they print that graph? Well, because there's a lot of dead space down here, right? They're not going to want to print this graph when they can print that graph instead. That takes up less space. But the problem is when you print this graph, you're misleading your reader because you're cutting out data. This is actually data down here. Just because you remove it like this doesn't mean the data's not there anymore. But your brain might not make the connection between the numbers that are missing here and the data over here. So why somebody would do it? 2 reasons. First of all, if they're trying to prove that Papa's took a plunge with their stock prices, chop the vertical axis, make it be something other than 0, which makes the graph look more extremely dropping than it actually is. The other reason I think is less mean is that this would take too much space to print on a web page. Nobody's gonna accept this much blank space. Although I'm surprised they don't just print these graphs and then put like corporate logos all over them and make some extra ad revenue, which is kind of the way everything works these days, right? Anyway, point being, watch the vertical axis on a bar graph or a line graph. Any kind of graph that has a vertical axis. If it doesn't go all the way to 0, be careful of how your eyes are perceiving the data in the graph. All right, my friends, you are now ready to try the last homework, which deals with this exact point. Go get 'em!